Hello everyone, this is KP the Math G here, as you can see from the cap there. Alright. Math G, this G here, what does it stand for? My students years ago gave me this name or title. They just started calling me KP, and then they said, when they saw that I was doing videos, they called me the Math G. Not genius. I cannot say G is for genius. Probably, if anything, maybe just guru, or maybe it's just G. I don't know. But anyway, whatever you want G to be, I guess. All right. Well, we're dealing with the 2022 free response question number 6. We are looking at part C. I abbreviated these as much as possible because I have very little board space. We have two particles, one going in the x direction, so that's why the x is here. Okay. This one is going in the y direction, that's why you have a y right here, by the way. So particle P is going in the x direction where t is greater than 0. Of course it is, because t can't be negative, so it's got to be at least equal to 0. Which they don't even make it equal to 0. It is greater than 0. P at t is equal to 6 minus 4e to the negative t. That is the position equation. We're going to need that for part D, because we're doing part C and D. Alright, so it says find yq at t, the position of the particle at time t. Now recall that yq at 1 is equal to 2. That's what we just wrote down right here. We're going to need that to answer our question. Now let's see. Vq at t. How do we change a velocity equation to a position equation? That's right. If you said take the antiderivative, that is exactly right. So let's turn over. I am going to have part D written down, so we're just going to have to ignore that for now. So let's see. V at t is equal to 1 over t squared. VQ at 1 is equal to 2. Okay. Alright, so VQ at t is equal to 1 over t squared. Now remember that, let's see, yq at 1 is equal to 2. Alright, now we need to take the antiderivative of this, so we're going to do this. There's no definite integral, although maybe you could set up a definite integral, but we're just going to do it this way. And this is dt. Now remember, we can rewrite this as t to the negative 2 dt. Alright, and that's what we're going to go by. Remember, we just really would like to have this as a numerator, put t in that numerator. But since this exponent is positive in the denominator, when we move it up to the numerator, it is going to be negative. And that's important that we understand that. Alright, so let's see. This is equal to, now remember, we're going to add 1, so remember this is t to the negative 2 plus 1 over negative 2 plus 1. You remember, you put that in the numerator, you got to put that in the denominator. I know that you're getting close to if you haven't already taken it, which I've been out of school too long to know whether you have. There is a mock exam. If y'all still have those, you do have, I think probably so you can get ready for the test. You got to remember these antiderivative rules, okay? And also remember, let's remember there is a plus c there. And we got to remember that as well. So let's see here. This is t to the negative 2 minus 1, which is t to the negative 1 over negative 1 plus c. Alright, so by the way, this is incidentally, let's go up here. This is, I can just move this negative 1 up here, can't I? See, I mean, 2 over negative 1 is the same as negative 2, isn't it? Over positive 1, isn't it? Okay, so we can move the negative sign up here. Let's do that. So negative 1, let's rewrite that, make it look a little more. So equals negative 1 t to the negative 1 plus c. I don't want this negative to be here, so let's do this. So this is negative 1 over t to the positive 1, or you can just put the negative on the outside, plus c. Now bear in mind this c is general, but now we can make it specific because we do have a point here. It's at this point here that we need to be concentrating our efforts on. 2 is the y, so 2 is equal to negative 1, and then 1 is the t. Alright, so 1 plus c. Just keep in mind the 2 is going on here, over here. The 1 goes in place of the t. Negative 1 over 1 is negative 1, so 2 is equal to negative 1 plus c, and then I add 1 to both sides, plus 1. So c is equal to 3. So now I'm going to plug that back in here, right here. So then now I have yq at t, yq at t now equal to, let's see, negative 1 over t plus 3. Alright, I'm going to write that down right here is equal to negative 1 over t. Let's make that t look a little better there. T plus 3. Alright. I don't know if I made it any better or not, but you got the idea right there. That's a t right there. Okay, now I need to go back. And that's part C right there. This is what we needed to find because we need this to figure out part 4. Alright, so let's see. Let's erase this. Part D, rather. Part 4, part D. Let's make that T a little bit better. I don't know if I'm going to make it better or not. We're going to try. There we go. Well, okay, there it is. Okay. Alright. It's kind of like Michael Jackson's nose. I don't know how many operations that man had on his nose, but it seemed like the more he had, the worse it got. But, well, he's passed away, so he couldn't defend himself anyway, because I'm here and he would be over there. But anyway, that's beside the point. Okay. I have a horrible sense of humor, okay? A dry sense of humor, if you will. So please bear in mind that I chuckle to myself. If it's not funny, probably not. So anyway, and that's what my daughter would say. I would get into a crowd of people and I'd tell a joke and laugh. I'll be the only one laughing, she said. She said, Daddy, when no one else is laughing and you're the only one laughing, you're entertaining yourself. Alright, so, well, okay, that's my sense of humor. Okay, so anyway, negative 1 over t plus 3. We're going to need the other one. The x, what is that? P at t? Xp at t. Let's see, I want to say that was 6 plus, I don't know. Let's see what it is. Oh, so it's minus 4e to the negative t. Alright, 6 minus 4e to the negative t. Alright, 6 minus 4 minus 4e to the negative t. Alright. Alright, now, as t, now I kind of boxed that in for a reason there. As t approaches infinity, positive infinity. Of course it's going to be positive infinity because t is greater than 0. Which particle will eventually be farther from the origin? Now this looks like I don't know what to do. I tell you, you just have to think about it just a little bit. We're talking about distance, aren't we? So we need both distance or position equations to figure this out. What does this mean here? What do you think we're going to be doing here? If you said limit, absolutely. We're going to check out these two limits and see which one gives you the biggest number, because further would be the one that's the biggest, right? So I think you probably could look at this and get a little intuitive idea of what this is going to be. Let's rewrite this one here before we go any further. Xp at t, by the way, is 6 minus, remember we could write this 4. Now this 4 stays, but this negative exponent can be brought down, and that may help us understand this. Alright, so let's take both limits. So the limit as t approaches infinity, let's start off with this one. Negative 1 over t plus 3. Now, what happens when t gets larger and larger and larger and t is in the denominator? Yeah, you can kind of imagine that. I mean, look at this. Negative 1 over 1 is negative 1. And even if we don't have to worry about the negative sign, but look at this. Negative 1 over 2 is, it gets smaller, doesn't it? Okay, right? Alright, so, and this is, you know, of course this is negative 0.5 here, right? If we want to look at this right here. And of course negative 1 over 4 is going to be negative 1 over, well, we already know that, negative 0.25. Alright, like that. Okay, this is actually smaller than this, right? Which is smaller than this. So this is going to get smaller and smaller and smaller. Think about this one. Negative 1 over 20 is negative 0.05, right? I believe that's right. That's even smaller than this, isn't it? So as you keep going, you just keep, adding more and more of it. This is getting closer and closer to what number as we keep going, right? Yeah, as we keep going, this eventually becomes 0, right, or close to it. Now it can't be 0 because t can't be 0 because 0 in the denominator is undefined. But we're talking about approaches 0. So let's just say t approaches 0, right? Alright, so as we get to infinity, this actually becomes 0 plus 3, which, by the way, if you just look at this, anytime you have a denominator, you know this is going to be this infinity is going to make this smaller and smaller and smaller and smaller and smaller and smaller and smaller, and eventually we just get 3 right here. Well, the same thing can be said here, right? The limit as t approaches infinity. Alright, so now we have 6 minus 4 over e to the t. Alright, I just kind of rewrote this. Again, I probably need to put that in parentheses. Okay, that's all of this. Infinity. Let's do this a little better. Okay. Alright, now, there we go. Now, this t is going to get bigger and bigger and bigger. E to any number is going to get extremely large, but in the denominator, what's it going to finally run into? Yeah, t is going to approach. As t gets here, then e at t is going to be 0 here, right? Or approach 0. I probably should have said, t does approach 0 here. E at t approaches 0 also. So this right here is 0, so this is just actually going to be 6. So this is, actually we need to probably say this is particle Q and this is particle P. Alright. Isn't that right? Yeah, this is particle, this is particle, so because 6 is greater than 3, okay, particle eventually particle what is it? Particle P. It will be farther from the origin. Then particle Q, if you want to say that. And you do want to say maybe because, this is okay to say because 6 is greater than 3, eventually particle P will be further from the origin than particle Q. Alright, that, or just say farther from the origin. If you want to chop it, I guess that would be okay. But that tells it right there. The key here, and I have to admit I have to look things up sometimes and go back and look at things that I've looked at before, you know, and say, oh, wait a minute, yeah, this is going to be a limit here. So I kind of thought that I needed to do a limit, but I had to compare the two, and that's what you're doing here. And I guess they're probably testing to see if you understand what happens as a numerator, as the denominator gets larger and larger and larger. This approaches what? 0. As this approaches 0. So 0 plus 3 is 3. 6 minus 0 is 6. And there we go. Alright, so eventually the particle will be farther from particle P, and you got to make sure you got the right one. Particle P right here is, it will be farther from the origin than particle Q, and that's all we have here. Alright, so you had to, in part C, you had to find this this position equation right here first before you could do this together as part D. Alright, so that's what you have to understand there. Well, anyway, that's everything that I have that I want to record here. I appreciate everyone. This is going to make, I have to look back at that again. I want to say this is the 152nd. If not, it's going to be the 153rd. So I have to look back to see which one it is. But anyway, that's quite a few videos, all calculus based, by the way. And most of these have to do with the AP calculus. If you're taking regular calculus, this could help you as well. KP the Math G signing off. If you want to, you can make a comment. If you want to, you can hit that subscribe button. I am gradually gaining more and more subscribers. But needless to say, this is not about me. It is about you. And then, of course, I say it's not about me because I'm smiling when I say hit that like button. I do like those likes. But anyway, I appreciate everyone here. I will tell you this. I have to study from time to time myself. Being away from this for a little bit forces me to have to study a little bit on these things, but once I study and get it, it comes back to me. And I want to kind of keep my mind focused on this, keep my mind sharp, especially in calculus and other mathematical related things. Anyway, this is KP the Math G, about ready to sign off with my signature clap. Ladies and gentlemen, I trust that you will have a great day. And again, thank you very much.